Right. Hi, everyone. I'm going to have a discussion today about mediation. And I don't actually know what he looks like. Is Nandan here? Nope, not yet. Okay. Yeah, Frank. Just gonna wait for a speaker to show up here soon.
Yep. Here, Martin.
Oh, okay, terrific.
All right.
All right, so I guess let's get started. So ideally, would like to talk about the different mediation options that we've got in front of us, and hopefully make a choice on where we want to invest.
Not a Hangout; it's a Zoom. So I don't know how to get it in our meeting rooms.
I see it. I see your doc on the screen at this point.
I do. I'm in the meeting room. Let me just share this here so people here can see it.
Oh.
Or USB-D or USB-F?
I have HDMI. Even that. Yes. 1 second, please.
As soon as I've switched to the latest Apple standard, I'm sure they will replace it with something else.
You know, the easiest way to do is you could actually cast from your web browser, cast your screen to the local room's
Well, we went low tech.
Oh, okay.
We
Zoom.
we used an actual wire.
I love wires.
Okay, so quick overview of today's subject. This is within an Istio. Well, Istio has an API management working group. One of the key aspects of API management is to do some lightweight mediation. Some common use cases of mediation are: I've got 2 or 3 APIs. I want to aggregate them and expose that as a single API. I want to do some conditional routing based on content. Routing could be based on payload. That's another aspect. Show and hide fields, translate XML to JSON. These are all typical things that an API developer would do. So how would this sort of a thing work when you have the Istio service mesh deployed? And then we have identified what I think are 3 patterns. I think, Spike, you mentioned there's a potential 4th one, which I thought was a version of the first one. But anyway, we'll go through these patterns. I can't see this picture now. Shouldn't there be a... Oh, there it is. This is the first one. All right.
Page breaks for those old-fashioned things we used to do with documents. Put them on, dead trees,
So this first pattern...
So maybe it's just me, but I don't see the document.
Yeah, I don't see anything either.
Oh, I'm sharing it on the screen. Can you guys not see the picture?
I see the screen, but I see you were typing a link and you were doing other stuff. I don't think you have that.
Yeah, we just see you left the video call.
Yeah.
Oh.
We see an old Go Meet. You were in Go Meet before. We're seeing that tab.
Why don't you stop sharing and restart share? That used to work in the old GoToMeeting.
Is there a way I can just share the whole desktop? That should be it.
There you go.
Is this?
Got
it. The old GoToMeeting trick still works.
Yes. Okay. I thought I was sharing. All right. I'm guessing you guys can see. All right. We'll discuss the 3 patterns very briefly. We can have a good discussion on the 3 patterns, pros and cons, and then hopefully we can pick one or more than one. The first pattern thinks of a mediation engine like Mixer. Mixer is like a rules advisor for Envoy, and the mediation engine is a mediation advisor to Envoy. So we can think of it as there's going to be another Envoy filter that calls a mediation engine. So we define a standard contract. Anybody can plug in their mediation engines there. Just like technically they could do with their own Mixer, mediation engine would be like that. Now, what happens in this case is that it is Mixer that advises Envoy whether to call the mediation engine or not. right? So when a request comes in, a consumer tries to access an API. And when I say this Envoy, this is the Envoy sidecar that's attached to the target, right? So this is the sidecar to the target. So it doesn't matter where the consumer came from, inside or outside the mesh, it doesn't matter. A call came in, this Envoy now calls Mixer and says, well, do I do some policy enforcement based on the traffic, OR tokens, quota, spike arrest, that sort of a thing? And then Mixer can also come back and say, hey, you know what, by the way, you need to go do some mediation on this before you call the target. At this point, Envoy will call a mediation engine. The mediation engine does what it does. It will have full access to the payload, which means that in general operation, Envoy does streaming, but when this happens, Envoy will not stream, will actually collect the entire payload, pass it off to the mediation under a standard contract. Mediation does what it does, sends that thing back to Envoy, and now Envoy forwards it to the target. This is on the request flow. Potentially, we could do the reverse in the response flow as well. So when the response goes back from the target to Envoy, again, it can check Mixer, should I do a response mediation on this, and then call the mediation engine, and finally return to the consumer.
So I see that you added that because right now, okay, that confused me. Because yes, the Mixer does not currently do anything on the response path. Got it.
Correct.
Okay.
Correct. And this would be an addition to that.
Okay.
Right? So now you have the flexibility to decide either at design time or at runtime whether you want the response mediation to even be invoked or not.
Yeah.
Right. So this is pattern one. I'm not sure how you guys want to do this. Do you want to discuss all three patterns or stay on this a little more and then go to the second one?
Since I have something to say, I'd rather do it interactive.
Okay, awesome.
So I'm currently exploring ways that we can do client-side checks. So before, in a client-server relationship, the client proxy would call check instead of the server proxy. I think this would just work the same way, right?
Yeah.
So one of the differences is that the cost, the overall cost of doing a check operation is moved to the client, right? So the client's proxy would be the one that's actually will trigger the mediation and will get the data back and do the extra work.
Sorry, I just want to understand. Sorry, I'm not on camera. Yeah. So to understand the protocol, it looks exactly like this. The difference is that it's the client envoy instead of the server envoy that does the check, right?
Right.
Kind of things work in gRPC. Okay.
In both cases, there's another envoy picture, right? Like there's an envoy either sitting between consumer and the envoy, or with what you're talking about, Martin, there'd be an envoy between the target and the first envoy.
Well, so in my mind, there's always a client proxy involved, and that client proxy might be the ingress.
Right, but there's an envoy basically between the consumer and envoy in this picture.
Yeah.
Because the envoy in this picture is the one that's sitting on the target side, really. Right?
Correct.
Yes. Yeah. But what you're proposing is this envoy in this picture is the one on the client side. But then would there still be an envoy intercepting input calls?
Yeah, necessarily because of TLS.
And the other thing is it's actually quite orthogonal, right? You can imagine the whole same train on the client side,
right?
Because you may have client side concerns that the client wants to enforce, and server side concerns that the server wants to enforce. So it's composable. You can have the same thing again. As an optimization, you can remove some of them, but logically, you can think of them as two.
That's interesting. So in fact, this says you can have outbound mediation and inbound mediation.
Correct.
So I've got my service that's producing requests in format X, but now I want to talk to service that consumes them in format Y, so I can do a transformation on the way out. And then the implementation that's receiving in format Y might also say, well, I'm implemented in format Z, convert again.
So the question becomes, who owns the mediation logic, right? Is it the provider that says, well, this is what I provide and these are the rules I want governed? For example, a quota is decided by the provider because they know how much they want to give out. It's not a client side. It's not, as a client, I don't get to decide it. You're right. You're not suggesting that the client decides it. It's just that the enforcement is there.
Well, no. So that's the thing. I think there's two things. First, quotas is totally legitimate to be enforced. So there's a like in the Google systems, we have a quota that's specified by the producer, and then the consumer can set its own quota that can be lower or equal. So they can use like kind of self-limiting yourself.
I see.
So in this case, what I'm suggesting is that in a communication, it's totally reasonable for a service that's making an outbound call to say, "Hey, I want to do a conversion on the way out."
Right.
That's my prerogative as a client.
Right.
And then it's my prerogative as a server to also say, I want to convert incoming requests on the way in.
I got it.
Yeah, I think the question, it doesn't really matter whether who's deciding and who has permissions to set these things. I think the underlying, there's really just a transformation happening between the consumer and the target, and whether it's actually being done on the client side or the server side is really
actually there are two orthogonal things. One is the point of enforcement, which can be independently decided.
Correct.
And then there is the ownership, like whose concern is this? So we've already used the example, which is again apt in this case, which is that PII scan on outbound traffic, right? That is a client-side concern. The client wants to make sure that it doesn't inadvertently end up leaking PII to some outside service. So that the client should be able to configure. And on the way in, like normal web application firewall style things, I want SQL injection to be performed before someone hits my service is a server-side concern. And again, the enforcement, we can orthogonally decide if we have good trust domains to move them around.
Yeah,
so I have a proposal.
That's kind of the point I was making too. It's like it's an implementation detail whether which end we put the actual check on under the covers, right?
Right.
Yeah, the thing that I find very compelling about this idea of moving the mixer check over, or allowing the mixer check to be done on the client side is it would let you, it would integrate, because right now routing rules are kind of done first, then we're over here into Mixer. Mixer has no ability to put some custom code in to go and muck around with some stuff and affect the route.
Exactly.
Independent of this particular API management use case, I think that's really compelling. That would really make the two work much more.
That's cool.
Yeah, that's what I'm going for, because I think also as we do API management in general, we do API decoding, job decoding. We'd like to these new attributes we're introducing. We'd like those to be available for routing.
That's right.
So, can you guys hear me?
Yes.
Yes.
So I propose that we should take this. This is a great kind of sequence diagram. However, we propose basically a couple of different architectures that this can be used in, and the sequence is identical, which is kind of elegant. But I think that we should add that and kind of have some potential deployment topologies and where and when these might be used and what the use cases are. Maybe we should add that to this doc or as a adjunct doc. So I think you Nandan, if I'm not mistaken, are going to propose maybe different alternatives, or you said you had 3 things you wanted to go through?
That's right. The three.
Right. This is one of 3. Yeah.
This is one of 3.
Right. So that's the thing. Like I think.
And just to the point that we just concluded, this pattern one itself has 2 variations, and I'm now convinced. Although I started off with thinking this envoy is on the provider side, I'm convinced that this envoy is on the consumer side, and then the mixer is affecting it, because then you can also do routing rules based on the mixer attributes. I'm convinced. So, but it doesn't change the mediation, the sequence diagram itself, but it changes the envoy. Whose envoy is that?
That's
so
exactly
I can
right.
update
and by
that.
the way, I think there are different topologies, because certainly that consumer might be holding a mobile phone, right? In which case Envoy is not sitting there.
No, but then Ingress does it. If you're outside the mesh, ingress does it.
That's right.
So I guess I'm still struggling with what use cases require this whole mediation system at all, right? Like,
yeah.
you suppose that we have a service mesh, right? We have routing rules. We have envoys managing all the traffic. So with the tools that we have today, it should be possible to insert a route such that the traffic between any two endpoints that you care about traverses a third service, which has access to the payload, which has access to headers, has all this stuff that we care about. Why do we need to propose this new thing?
Right. This is the whole question of, do you just write more code, or do you provide a mediation engine that's configurable and that does things for you?
But is this one of your 3 proposals?
Which one?
Is one of the 3 proposals, it's just a proxy?
No.
So that's like proposal 0.
Yeah.
Proposal 0 is there exists a proxy that is a service running on the Istio mesh, and you can, which is I think Munder's proposal from several years ago.
It's actually, sorry, it is there, but I call that an anti-pattern.
Okay, so the key question is,
we're going to have a pattern anti-pattern reaction.
Yeah.
The key point is, this is a common pattern. Do we believe there's value in us supporting this as a first-class concept, or is it okay to do it in an ad hoc, let customers do this in an ad hoc fashion? Right? Can we build tooling? Can we build better observability if Istio has a deep understanding of what this is? That's the question.
Well, the protocol for mediate could be very simple. However, there is still nothing out there that does that.
That's right.
There are a lot of proxies out there, which is the advantage of the anti-pattern of having just a proxy. But if we make this protocol simple enough, it could be a place where a lot of value could be added.
Right.
Could you give some examples?
Scanning content for PII.
No. I mean, give some examples of where the new pattern adds more value than the existing proxy pattern.
Let's say that I want to aggregate 2 or 3 APIs and then expose that as a more of a composite API. And then based on the JWT token I get, I want to show or hide fields from it. Now, one could definitely write code for it and just deploy that itself as a 4th API. That's certainly one way of doing it. Or you could introduce a mediation engine where the mediation engine can decide when I want to expose just one of that API. Sometimes I want to aggregate 2 of these APIs. Sometimes I show or hide fields. You're sort of consolidating that logic in another layer instead of building more microservices.
But even that pattern calls for a standard service you can inject in the mesh and configure.
Yeah.
But the mesh knows nothing. It's not special to the mesh.
That's correct.
Yeah.
Yeah, there's 2 different discussions here. Again, one is sort of there's a mediation service that might do some cool stuff that's, whether it's running as a service, pattern 2 or pattern 1, it's some kind of built-in mechanism. But the real question, there's 2 separate things here. Like, do we have such a built-in service, a mediator that you use, or everyone just writes their own? But that's completely separate from whether it's being called with some special mechanism that we build into Mixer or into the Envoy, or whether we just use route rules or things like that, right? So are we clouding these discussions by, I don't see what use case says that the implementation mechanism warrants going with route rules instead of this pattern 1, 2, or 3, basically.
Well, so the pattern 1, 2, and 3 would be more efficient in the event that most of the time you don't mediate both the request and response.
Yeah, see, I added a comment into this document just
Not
today.
necessarily, right?
I don't think that's true.
The route rules can take advantage of all kinds of information and still make a decision about whether or not to go via a mediation or directly.
Yeah, exactly.
I don't think that you're not like changing the fundamental capabilities of what Envoy
Okay.
can do. in terms of whether it includes mediation.
So I think I mean, if we so far prior to Lua, you could not express arbitrary logic inside Envoy. With Lua, you can actually express arbitrary logic with whatever you want, and then you can actually make a decision based on that. So with that, yes, it is possible to make an arbitrary decision based on some things and say, okay, that's where I'm headed.
Do we conversion to Mixer being called on the client side Envoy as well? You get even the ability to put Mixer in, do some of the mediation things itself, and if it can't, then pass back some flags in some way that Envoy now, a route rule will kick in that will now call a mediator. So you can really do clever things, especially if you get Mixer called before routing, right?
Yeah.
Yeah, Mixer call before routing is definitely a good thing. Yeah, I'm convinced now that if we go with, I mean, if pattern 1 is a thing, then it should be done so that the envoy that's depicted here is really the client-side envoy.
I think it is still orthogonal, right? I mean, we did go through cases where it makes sense that if it is a server-side concern, then you want that to be under the server's control.
Yeah.
And if it's a client-side concern, then you want it under the client's control. So where it runs are independent decisions based on whether security is paramount or performance is paramount or all those things. I don't think this actually dictates one or the other.
Correct. So there's a logical model where a service decides what reaches it and what it produces. So that's what the operator is configuring.
Yep.
And Istio will figure out where's the best place to achieve this objective.
Is it Istio to decide? Or I was thinking that there'd be two kinds of Mixer rules, right? One that the provider defines, one that a consumer can define, and then both are executed by the client-side envoy, but I don't have to change. I don't have the permissions to change the server side or the provider side.
No. So that's the thing. You get out of that mindset. There's Istio as a whole is in control of all the proxies, and they're trusted. So the intent of the service producer might be convert incoming traffic in this form, or convert outgoing traffic in this form. And then Istio will decide where's the best place to do this, on this client proxy, on the server proxy. Maybe it depends on the load, maybe it depends on the shape of the data, whatever. So you could have an environment where you said, okay, we have a highly provisioned target service. It's got the capacity to do all this mediation itself. So we'll do both the client side stuff and the server side stuff all within its proxies. Or the opposite, right?
That's kind of hard to explain to the enterprises that Istio will decide. They'll want to know how can I change it? When does it make this decision and so on. I think we'd be complicating explaining how this works to the enterprises.
But that's the thing. The user is manipulating the configuration in completely meaningful ways from the user standpoint.
Yes, agreed.
And then we migrate the computation to where it makes more sense. So yes, there's a level of abstraction there.
I think the envoys that are being configured under the covers is sort of like the compiled code, not the input code that the operator's kind of writing, right?
Exactly.
Yeah. Right.
Right. So the more we look at this model of having a split between what the user writes and what the system runs, more opportunities there are for us to be smart and to optimize things on behalf of the user and simplify their life.
Okay. So what I'm understanding from you is there will be some optimization done for which envoy will actually enforce the rule, and that will be done based on the rule itself.
Correct.
Okay.
So now if we have these basic mechanisms of Mixer can influence routing, both on the server and on wherever it influences routing, then is that a sufficient building block that we can just stop here? So if you want to do Mediation Engine, this is the pattern you need to follow, and we're done?
Let's look at the other two or other three,
Okay.
and then maybe we pick whichever we think is right. Okay. The second pattern, I think, largely works. And Mandar, please correct me if I'm wrong, because this was inspired by what you wrote. Is what Cloud Foundry does with route services. Right? And this is inspired by that. So this actually, and Spike, to your point, this brings in an intermediary service. It's a service in its own right, but it's a special service, an intermediary service. It's not a regular service. So Istio Service Mesh can know about it, that this is not the final or the actual service. This is a place that consumers go to before they get to the actual endpoint. And it is this intermediary service where you plug in your mediation engine. So this is, have I captured what this does correctly, Mandar?
So at least in my proposal, Mixer is not really present, right? Because because at that point the whole Mixer is kind of orthogonal.
Yes.
The main point is, can you how do we model an intermediary, and
yes,
what are the tools that we need to model an intermediary?
Yeah.
So with that, essentially all you have to say is normal route rules say service whatever source A to destination B, and now we can say source A to destination B via Istio service C, and then that is a concise way of expressing what we want at the routing API layer.
Right. But now the intermediary cannot change the route, or can it?
Intermediary cannot. So no, intermediary cannot change the. Well,
in CF it can.
No,
yeah.
Normally it cannot, but potentially it could. But the main way was if your purpose is from traffic from A to get to B through C, then C should not really change it, right? Like,
no,
so
that's the thing, right?
you can shut it off. So you can say, okay, I'm going to stop this, and I'm no longer going to send it out. However, C has full control of the request. Like, C is the proxy at that point. So just like any proxy can do, it can send the traffic wherever it wants, really.
Right. So if you imagine this use case where I want to hide the versions from my consumer, and then based on who the consumer is, I send them to the appropriate version. In that sort of a use case, the intermediary is the actual one that decides where the traffic should be routed to, and it decides that maybe on the consumer's identity or something in the payload or something to say, okay, you belong to version 1, you belong to version 2, and so on. So it becomes
that use case sounds to me like just plain basic route rule use case. That's not really even an intermediary use case.
Well, except it's looking at the payload.
Based on the payload. It's based on the payload.
Can you explain the extra envoy that you have there? Seems like they participate at different times.
Yeah, the Envoy 0, I believe, and I should check, is the consumer's envoy, and Envoy 1 is the intermediary's envoy, and Envoy 2 is a target's envoy.
Right, and the response goes back, when you get the response back from the intermediary, that's on the return or on the request. So I'm assuming it's always on the request, right?
It's both request and response. The response also flows through the intermediary, because the intermediary may decide to do something else with it before the response is sent.
Okay.
I think this picture is really just using route rules today, where you would set one route rule that says the calls from consumer to target should go to intermediary. So there's one route rule that says that, and then there'd be another route rule that says calls to target where the source is intermediary should go to target. So if you have those two rules set up, this is exactly the flow that you get. I think Mandar's proposal was to enhance the routing model a little bit so you could avoid some of this and make it a little more clever by having special type of routing rules that avoid, that basically say go from A to B directly in one rule, but use the intermediary and throw the intermediary into the path.
You don't necessarily need that second rule because, like, the default, if intermediary sends it to target, is for it to go to target. So in that case, that second rule is redundant, which is probably the
no. That's not correct. So these are operating like at pretty late, right? This is after routing, so just destination doesn't carry enough information on the other side to really say where it's headed, right? You may have source aware routing on the source, so there is more context that needs to go into the next hop.
Right. I think the intermediary has to know the original host, the original destination.
Just using host is not going to be enough. You need to know more than just host. You essentially need to know what decision did the original client-side proxy make, and the intermediary has to kind of honor that decision, which may or may not be the host.
I mean, what more information does the intermediary need?
I think that we also need to somehow translate security rules into this, where there may be a rule I've defined that A cannot invoke B, but now that I introduce an intermediary shouldn't mean that that rule is now no longer enforced. So A's security context still needs to be passed along, so now B can still reject it.
And can the intermediary apply some filter, right, in the response also, right?
Yes.
Yes. Filtering, like an intermediary can do anything it wants with filtering. But on the way out, in order to make, so again, if you have source-aware routing at the source, and based on routing rules, you have chosen a particular upstream cluster. The upstream cluster has more information than just the host. So we want the intermediary to make the same. We want to give the intermediary the ability to make the same decision.
What information is the intermediary missing?
The source information.
Won't it get the source when the source sends it to it?
No, I think what you're trying to say, Mandar, is by the time the traffic hits the final target service, you want the source information at that point to not indicate the intermediary, but the original guy.
Yes, somewhat, but the intermediary just is going to know the IP address or something like that of the source, which is not a complete information about the source, right?
No, I mean, if you're doing mutual like authentication or something like that between the envoys, like you'll still get the source information, or at least the intermediary would have as much information about the source as the target would have, right? Whether it's mutual TLS, so you get SPIFFE IDs, or it's just normal HTTP, so you get the IP address and you have to look it up somewhere to decide what pod it is. Like the intermediary gets the same amount of information about the source as the target would have gotten.
Yeah, so that's why I think the real problem is the fact that when there is an intermediary, the target will not see that information.
Correct.
So I think that means if you're trying to apply policies on the target, it's not going to work the way you want it to. You need to apply all these policies on the intermediary, which I think is broken.
Yeah, and you'll have to do it twice. You'll have to first move all your target policies to intermediary and allow intermediary full access to all services and push the responsibility now on the intermediary.
So now, to me, this is a motivation for Istio to understand this pattern as a first-class thing, so that we can erase these ugliness.
I don't think that this is particular to this sort of mediation use case. Like you can think of ordinary processing environments where service A calls service B, which calls service C, and service C might care who service A was, right? Like that's a general thing that we want to tackle. Like that's not specific to this sort of mediation use case.
I agree with this, but if mediation is a sufficiently common pattern, it's worth having a solution for this somehow.
I mean, the reason why I keep coming back to the solution, even though I know the other ones are more interesting, is that there are lots of things in the world that know how to be a proxy.
Yeah.
If I think about the people who are going to be consuming Istio, oh, I need a proxy that converts my my SAP to my REST API. Oh, I have one right here. As opposed to anything else we're doing, we're really talking about creating brand new contracts that people will have to write software to support. So that's why I think it's worth getting this right.
I agree on that.
The first thing we have to do no matter what, right?
And I think that like the security goes both ways, right? The target might care that it was what the original source was, but you also have to consider what the intermediary was, unless you're just assuming that intermediaries are always 100% trusted, things that you don't have to think about what the policy is there. Like an intermediary has a lot of power, and so you probably want to understand what trust relationship you have with that intermediary as well, which means that like in general you're going to want the target to have both the original and intermediate.
Exactly. The target must get the intermediary's identity as well as the original. So the security context from the source must be passed on so the target can decide, but also must independently establish trust to trust the intermediary.
And then you've got to think about what if there's an intermediary for the intermediary.
Yeah. And if you introduce
you
multiple
either have a way to protect
intermediaries,
that, or you got to come up with an architecture for that as well.
Yeah.
Strikes me as there's an intermediary generic engine implementation that we write and provide that's a very trusted thing. It's doing all the right stuff, and that one's safe. And then the other type of intermediary would be ones that the application decided to put in themselves. They wrote some service that they want to plug into this picture, and then it's they have to trust their own stuff, don't they? So then
it's not about trusting the code that they've written to like execute faithfully. Like any of these things are going to be network endpoints and could be compromised by an attacker moving through your network.
Yep. Absolutely.
Yeah. I worry about the usage model of this. Where are policies applied by the operator? If we hide the intermediary as basically it becomes an implementation detail of a service, then I don't need to think about it when I'm applying policies in general. Like this intermediary can talk to me, just like the proxy is. We glom on the proxy to services, and they effectively become one. You could imagine this intermediary logically disappearing, and it's just an implementation detail of between the proxy, between the time the traffic arrives at the proxy and is delivered to the service. There's this extra thing happening, but it doesn't count in the policy model.
But
so that's what I'm saying. I don't think that works as soon as the intermediary is in a different trust zone than the source. Right, the envoy that's next to the source is in the same trust zone, and so it's fine to sort of collapse those things in terms of your policy model. But the intermediary is in a different trust zone, and so it's definitely not fine to collapse them in your trust model.
Yeah, I agree with the general point. I wonder if there's a way to.
I also want to add that it's quite possible and likely that the intermediary is a shared intermediary that's owned by another team.
Yeah, that's the problem.
That's quite common, and the intermediary isn't even necessarily in the mesh.
Yeah.
Yeah, that's harder.
Yeah.
Well, wait. You want the traffic to leave the mesh and then come back in?
Yep.
Yeah.
I'm surprised everyone is so sure about that.
I was hoping the answer is no, because then you don't have Envoy, you don't have all those other things.
Yeah.
The intermediary, it's much harder.
Is it because this use case is for when that it's something where you can't easily put it on the mesh? That is, you can't deploy a sidecar with it. Is that why there's?
Yeah, so some SaaS provider has some transformation service, and you want to use that.
You ask the SaaS provider to Istio enable that mediator.
Well, but we have the foreign service support.
Yeah, exactly.
So that should just kind of work.
Well, you have to go through a few other steps to make it work, because now the traffic has to come back into the mesh. You have to configure ingress, or you have to have special.
Well, no, it depends on how the traffic comes back in. Right? If it's just a response, then it should just work. Right? So so the mesh sends a message out and then gets a response back, and then life goes on.
Yeah. In many cases, the service outside of the mesh to which the requests are sent is in turn forwarding requests to the target, which may or may not be in the mesh.
Yeah, that wouldn't work. Yeah, so the pattern I described only works if it's I send it to the intermediary, it responds back to me, and then I route it.
Yeah, I think this pattern assumes the intermediary is in the mesh. Yeah. If we want to address the not in the mesh, then it's a separate pattern, and I think we should view it separately if that's a valid use case. Should we bring it?
If it's outside the mesh, you could have an intermediary inside the mesh that talks to the one outside the mesh.
Yeah.
Yep.
Yeah.
Unless the only problem is if that intermediary outside the mesh now wants to go directly to the target, we've broken the chain.
Right. You have to have a separate protocol for that.
But the idea is to apply as filters, right? Like the way I'm seeing this is more like filters that you can ask someone outside of the mesh to handle for you, and you just inject back in the mesh.
That's right.
Okay, so we'll park this. In the interest of time, we'll go look at the other options and then compare them. Pattern 3 is to change something that from the behavior today. Well, all the previous two patterns also did this, but essentially, Mixer now receives the payload when this adapter is enabled, and the mediation engine is an adapter to Mixer. And now, so we just treat it like anything else. Mixer is not just header and the URL; it gets everything. And now you can choose to decide what you want to do with it, pass it off to another service, call an intermediary in, outside, in the mesh, doesn't matter. This is just now a service that you can plug into Mixer. But now you have to follow the Mixer's contract, whatever interface we define, that's what the mediation engine will have to implement.
So it was on a previous call, it's decided that, yeah, this would be a nice pattern for the cases where you don't have to have access to the request body and you're just, mucking with headers and things like that. Or there might be even some optimal subset that you can do this way, but then the mediator that has to be called externally as a separate thing is a use case that is still going to be there. This covers partial, some of the use cases. Is that sort of still the thinking?
With this, you can call an external mediator. I mean, as long as you're writing the adapter, right? You can then forward that request to anywhere, to any place you want, right? So it's just that, again, back to the original point, that it has to be a request response. You don't want the target now going directly, the intermediary going directly to the target. Same restrictions apply here, but now there is a place for people to plug in their mediation engine, the contracts defined. It's very similar to writing an Envoy filter and going directly, but now you're going directly from Envoy, like in pattern 1. In this case, everything goes to Mixer, and now you have an adapter that's enabled or not.
Oh, I see. So your payload is being sent to the mediation adapter. I think that's something that doesn't work, and the discussion was that wouldn't be easily implementable. Did I miss something?
Well, I think it's reasonably easy to implement. It just kind of breaks some of our assumptions in terms of scaling and what the kind of the work that Mixer has to do. It would now suddenly need to shovel potentially a lot more data, and that changes the equation for it.
Only if the adapter is enabled.
Correct. But in that case, then suddenly Mixer's kind of general execution profile is vastly different than in other cases.
Yes.
And I say the same thing every time, but if the mixer
You can talk.
help a lot, because then you wouldn't need this mediation as much.
I didn't get that. You kind of broke up.
If it was possible for a mixer adapter to change the headers, or maybe even look at the request body, that would reduce the percentage of time that we even need this mediation.
Yeah, which is what this will do, because your mixer gets it. So, yeah.
Oh, interesting. Yeah, so having Mixer change.
But how much extra load we have on Mixer?
Yeah, and Martin, to your point, we could have some optimizations of, pass me only the headers, but then allow the adapter to edit those headers, to add, modify headers. That's also a key thing that will be satisfied with this, that adapters can modify the content. That will, again, reduce the need for other mediation engines if we can rewrite some of these things.
So we could support rewriting headers almost today.
Yeah.
Even the protocol supports it. We just would need to add a little logic in the proxy. So that shouldn't be too hard.
Right.
I could also imagine where are there patterns where you don't need all the data, all the payload, and just like maybe the first K of it or something, or is that?
Yeah. I mean, it's not
like first 100 bytes is common for IDS or like WAF kind of.
I hate to say it, but they're still out there back in the SOAP days. You need to look at the SOAP headers, but not the body. Yeah, and also even things like certain kinds of content validation. Yes.
Yeah. Okay, so if we want to say on a based on let's see, what policy would this be? Based on some configuration of some sort, for a given request, the proxy will send n bytes of the request payload down to Mixer, and that the n can be adjusted by the user. It probably wouldn't make a difference to the Mixer's overall pattern if n was less than a k, say, for example.
So Martin, I'll give you a different use case. You tell me what's the right fit for this, right? Say I want to do some general threat protection where I, as a provider, don't want to accept 10 megs of data. So I want to filter that out. Right? So I just want the content size to not exceed 5K, 10K, whatever it is I decide. And if it exceeds that, block it. I want to be able to specify some rules like that.
So you can do that today.
Okay.
There's no, that should just work. You just do in fact, you don't even need an adapter for this. You just express this in Mixer's expression language.
Yeah, because you get the content length header, at least for HTTP, it works.
Yeah, and I think we have an attribute, request.size.
So if it is just bytes, yes. But what if I want to get a little more specific about JSON, right? I don't want to have a very nested JSON, right? 5 or 6 levels as far as
so then you need to start sending some of the payload down.
Correct.
So if the payload is small, it really won't hurt Mixer at all. It's just if suddenly Mixer starts getting these 10 megabyte chunks of data with every request, then suddenly Mixer's QPS is going to go down the toilet, or SLO, whatever is going to drop.
So are you dealing with only a read-only kind of scenario for the adapters, or are they going to be able to transform and send back the 1,000 bytes?
It would be a common pattern to send version 1 of your API schema in the payload and want your mediator to transform it into version 2 of the schema.
That's correct. That's a very good pattern.
But you can do that even for if you have a subset of the payload?
No,
you need the whole payload.
Yeah, that's the problem. I think Martin's proposal here is that the mediator is only capable of looking at some subset of the data, a maximum of the first 1,000 bytes or whatever. and then you don't really have the ability to do a transforming type of mediation. You can only look at it, maybe say, check off this looks good, and send back this is fine.
But I think it provides an interesting way to kind of chip away at the problem, where there's fewer and fewer cases where you need the big guns, and you can use the smaller solution.
I agree, but I don't see this as chipping away at the problem, but as looking at optimizations of the, just doing an extra hop to do this work, right? That's all we're talking about, which I think can come later is sort of my overall thinking. Like, I don't think it's a bad idea to be able to optimize these cases, but, I think we get something up and working without any of this initially and then start optimizing these cases later, right? It's all under the covers. As far as I'm concerned, it's implementation.
Okay, so to me, the minimum work we need to get something running end to end in a meaningful way is we just treat these intermediation guys as regular services in the mesh, and the only addition we provide is some sort of a forwarding of attributes so that the target service can understand what the original source was. This intermediated source is, as opposed to just, so that way you can express policies in a meaningful way.
I think, Martin, we need a portion of pattern 3 to be allowed in the rewriting of headers. I shouldn't require an intermediary mediation or any of that to do some of those basic changes to the message.
Yeah, so that we can throw in fairly easily, and that should just work. So let's take that as a given in general.
Right. And two more things to that is calling Mixer on the response side, and for Mixer to effect routing changes.
That's huge. You can do that. That would be, I think, that with existing route rules will give you multiple use cases, I think, right?
So these 3 things, I think, will shrink the need for any other mediation type things, and then for what's left, we can pick pattern 2 or whatever to solve what is left.
Okay, so I buy that. I'm not making promises on client side check and that kind of stuff. There's security implications that I'm trying to work out in a meaningful way. It looks promising.
No, I think that this again, depending on what your use case is, Nandan, I don't think these are. I mean, I don't think we even need this to solve some of the problems that you're mentioning, right? Like, if you have a real intermediary, which you can just have a proxy that's inserted, it can do everything.
No, but my point is, I shouldn't introduce an intermediary for some of the simple things. Why even?
So the simplest things. So, for example, the fact that we cannot get headers back from Mixer right now, that's just an omission, right? Like, consider that as a missing feature from Mixer, which we will implement. There is no doubt about that.
Yeah.
The client side, like affecting routing, that's a whole new thing. Which so the question is that, or just insert another a full proxy in the middle. Both those kind of give you the same thing, and you can have the second one now, right? But essentially, the VIA just kind of exposes it and makes it first class. You can use route rules and, like, I mean, you'll have to use them correctly, but you can use them and you can make it happen today. So my question is, what is specifically, like, what use case is driving this particular pattern?
No, all 3 patterns solve the same problem. It's just 3 ways of doing it. I don't think there's one that solves it. Solve something that.
But you can't do it today because you can't arbitrarily change the routing, right? I mean, based on the request, like on the request body. If I want to change the routing, I can't do that today.
So you can always route it through an intermediary for the first pass.
Yeah.
It's efficient because you'll just always have this extra hop even when it's not necessary, but you could get something up and running. If you scroll down to the very bottom of this document, Nandan, the very last comment at the very bottom of it, I have a link to. I did this. It's just a little example. If you click on that little, very, very bottom of the.
This is.
To the comment on the far right, there's a link to a GitHub verifier thing.
I see because how do I?
Yeah, the verifier, right?
Yeah, if you click on that link, and you can see that I did basically a little experiment to just show this is how you could make everything transparently go through a intermediary. You know, obviously that's not the most efficient. It's right at the bottom.
It's at the bottom there, none. You were just there. It's on the bottom right there.
To the right that says there's a link.
Down.
I can go. This is the bottom.
He can't go down because we have to screen Zoom video conference.
Click. Oh, you were right there.
You hover over it and click the little close back. Okay, now there we go. Yeah, there's a Zoom video conferencing screen.
I'm not going to see you guys.
Oh, you don't work for Google, so you can put stuff on GitHub. That's awesome.
But yeah, if you just look at that little route details verified YAML there, basically it's just showing there's two rules that you have to set up. One that says, this was basically just saying that I've set up a little intermediary that basically verifies one of the, basically verifies the one of the fields of the details coming back. And basically all this is doing here is there's two rules. The first one is basically saying that when you send traffic to details, it should go to so anybody making a request to the detail service should just go to this verifier thing instead. And then the second rule basically says, unless it's the verifier who's making the call, then you send it to the target. And all I basically had to do in the verifier was do its verification thingy and then look at the original destination and forward to it. That's all it does.
So I think in my mind, this is a fine mechanism, but it's not really the right UI to expose to our customers.
I agree. But I think the point is the mechanism under the covers that's doing it is there already.
Correct. But if you imagine there's other services in the mesh that are talking to this thing, they might apply policies on their behavior against the service, and now you're coming later and say, oh, I want to insert this intermediary that's doing virus checking or something.
Yes.
And now it changes my service relative to everybody else. And the rules that I had defined on my service itself no longer work because all their traffic is going to come from the intermediary instead of from the real target.
Right. Exactly.
I think we need to fill in those gaps to make this useful. That's where having this notion of intermediary as a first-class thing kicks in, I think.
Well, if this intermediary was just a well-known kind of standard service where this code gets called, where my actual intermediary, it's a little Python thing. It's part of this example. You can run it. It's trivial. It's this little Python thing. But, the bottom line is that if there was this trusted verifier service, in effect, that we've provided, instead of, me just applying this little Python, service, then, certainly you could start to do these things. And more intelligently routing to this mediator, not based on match criteria, which I haven't done here, could say, yeah, the mediator doesn't even get called for a lot of the cases. And yeah, as soon as you can do the client-side Envoy stuff, or the client-side Mixer stuff, then you really got something nice, because then, the first pass is this goes up to a Mixer adapter that can decide to do, whatever, header transformation, whatever, the various things it can do. Look at the first 100 bytes or 1,000 bytes, or whatever, and in those cases, it'll then just come back and say, fine, don't muck with the routes, don't set the match criteria so that it'll do the verifier path, and instead just go to the target. And in the cases it says, oh, no, this is something that has to have full access to the request body, and it's going to do a transformation or something like that, then it just basically flips the switch so that the match criteria of the underlying rule now goes to the intermediary. So I think my point I'm just trying to make here is I think the underlying mechanisms, like the machine code of under the covers, there's this stuff, and I don't, I kind of, Mandar, I'm not saying that VIA thing might not be a better way to do it, but again, I think it's just an optimization under the covers. still, because I think the whole configuration of this thing is at a higher level than any of this, right?
Yeah, so I think that the VIA thing might give you just enough hook for Istio to understand what's going on. Right? I'm not, because this is effectively changing the identity of a service by adding this intermediary in front, whereas the VIA thing is not.
Yeah, I think that's true, because the Envoy is sort of magically, doing the intermediary thing, but there's still clever stuff that's happening with the VIA design, and that the intermediary is really just a service running in the mesh that the Envoy is going to call. It looks at these special headers and decides who to pass the request on to.
Right, but I think like it does go back to that whether there is a first class notion of VIA or an intermediate or not, right? In this case, we're saying there is not, and the user just achieves that effect directly by programming route rules. And VIA actually gives you a way to model that, and then you can build on top of it. But now the system knows that there is this thing in the middle, clearly.
Yeah, there are two use cases to consider. One is I have already built some security rules for my service, and then I introduce an intermediary. Do I need to change anything to those rules? Do I need to rewire it? I make those rules aware of the intermediary is one. And second is the passing of security context to the target so that the target still knows who actually called me. It shouldn't just look like the intermediary is the only thing accessing me.
Yeah, no, I think the intermediary though has to be a very trusted participant in either case, whether we go with the VIA thing or not. Because in both cases, it has to very much follow some protocol of how to pass things on. Doesn't it matter, or is that being done by an envoy attached to the mediator?
No. It has to be trusted. Like if MTLS is going to terminate at the intermediary, the payload is going to be all available to the intermediary. So whatever trust is needed to make that happen has to be there. And then on the other side is actually a little bit different, right? The target can decide that the target should have identities of both. It should have the identity of the original host and the intermediary, and at that point it can decide whether the thing should go on or not.
Correct.
Yeah, so you said that like the VIA allows Istio to know that the intermediary is in the path, but actually Istio already does know that just with these two route rules here. What Istio doesn't know is that particular requests that go into this verifier are correlated with requests that come back out of that verifier. And that's the piece that's missing and would be required, especially if these verifiers are shared between multiple services. If it's not just a sort of straight.
Yeah, it's depending on the verifier has this magic kind of inside of it to do that stuff. But with the VIA design, the verifier, yes, the route rule kind of explicitly shows that that's the case, but the verifier is still responsible for doing that magic too, right? The same magic, more or less.
Right, but my point is that mechanism of being able to correlate incoming requests with outgoing requests on particular services is generally useful, and we've been talking about in the security group, and applies not just to these sort of pass-through transformers, but to more traditional microservice architectures where some request comes in and that triggers one or more outgoing requests that you want to be able to, from a security perspective, correlate the incoming request with the outgoing request and who made that incoming request.
So I guess I see that as a complementary features. So to put a plug-in for the config architecture that we're working on, again, there's a distinction between what the user writes and what the system runs. I think what Frank wrote here is what the system runs. But what the user writes, the user wants to say, my service has these policies against these other services. And if there's 15 proxies between me and the other service, that's an implementation detail. If there's intermediation stuff between me and that other service, there's implementation detail, because my policy is about
except when it isn't, though. That's the point, is that sometimes it may be, if it goes through this intermediation, now that changes how much I trust it.
Right.
Correct, but is the common pattern sufficiently common that we can say, look, this is the behavior that we provide. If it's not sufficient, you need to break the glass and kind of roll your own at that point. Because the pattern that Frank showed is imminently achievable today without any change to Istio is just not, I consider not a pleasant user experience. So can I address a 95% case with a nice user experience and leave the 5% to go to do it the hard way? Right. So in terms of spectrum of solutions here, I think we've explored a few different things that can cover this spectrum. So allowing the mixer to rewrite headers, that's one thing. Allowing the mixer to influence routing decisions, that's another thing. Allowing the user to express intermediation using kind of this high-level mechanism is the next part. And then finally is the we don't care, do what you want using the core building blocks. And you kind of covered the gamut there.
I think we're sort of agreeing, though, that there's not one solution here. But all these solutions are applicable for certain use cases, and more from an optimization perspective than a just doability perspective. Like the worst case scenario, you have to hop out to some service. I think is what we're kind of leaning towards. Maybe not. But at the other cases where you can do it in Mixer, you should do it in Mixer. But I don't know. Does anybody so strongly still feel that this idea of Mixer directly calling some kind of intermediary service makes sense?
Keep in mind also from a Mixer standpoint, although right now the adapters are built into Mixer, we're kind of moving to a model where Mixer is going to call out to external services via RPC call.
Yes. This is why I find that very tempting, because it can already have the ability to call something external. Why invent a whole new mechanism for it? Just make it an adapter.
What's the time frame for that?
Because the use cases are slightly different, right? If you actually want real transformation of content, then you cannot have a Mixer adapter.
Why? I mean, sure, not today, but if Mixer had the payload.
So for Mixer to add payload, right, if you have, like, the protocol will have to change. Like the first 100 bytes works, but first 100 bytes is again not useful for content transformation.
Yes.
So we could still do what Mixer is normally intended to do, which is look at headers, make decisions, and send back some headers. That is actually orthogonal to intermediary or not, right? How those headers are used once they get back to Envoy is a separate story.
Yes.
And yes, those headers can be used to decide, oh, well, now the route changes and therefore it goes to an intermediary. But I don't think that, so especially from a content transformation perspective, I don't think these two things are very closely linked. They're complementary, but they're not closely linked. We cannot do content transformation fully in Mixer because we would have to start streaming, or Envoy will have to read the entire content in memory and then send the whole thing over, like both of which I don't think we really want to do. So the first 100 bytes, first n bytes works, but now we can't use it for transformation.
Correct. But it just means that some of the use cases, if we don't do anything compared to today, there's a lot more use cases that require a full separate service running to do the intermediation. And if we just start adding a few features in Mixer here and there, we can eliminate a lot of these use cases and just fall back to the basic infrastructure without an extra service.
Yeah, the other case that I would point out where you can get a really long way without introducing another service is making use of Lua filters in Envoy and giving service owners access to that in a well-defined way via Istio means that they can do little, tweak this header, change this payload, all of that kind of, especially stateless type transformations can be handled directly in the proxy.
It'd be interesting if we make attributes, all the attributes available to Lua in some form, so you can address that state.
Yeah, we most definitely. I mean, we're already seeing like use cases where, people want to do just that. So
I feel that that's against the philosophy of Istio. This may sound controversial, but if we just write Envoy filters, don't need the rest of I don't need Mixer at all, right? You can just put in a big Envoy filter to do everything.
Yeah,
I think that is, if you're sold into just the Envoy ecosystem, then yes, that method works well, where you've just bought into Envoy and not the rest of Istio. We shouldn't have 2-3 methods of, yes, you can write Go adapters, now you can write some C++ or some Lua. It's just too many things for someone, too many options for someone to have.
No, so hold on. There's yet one more choice that actually simplifies things.
Okay.
So it's my intention that perhaps maybe around next year, Mixer starts, based on Mixer config, Mixer will produce Lua scripts that it sends back up to Envoy dynamically. So the intent there was so that the first use case for this is to have basically the ability to create a sophisticated cache lookup based on Lua scripts. So improve the efficiency of the cache. There's nothing preventing us from also sending up slightly more sophisticated programs over time to achieve these behaviors. It's strictly for efficiency's sake. So the user model remains the same, but suddenly computations move to the proxy, and in more cases, you don't need to talk to Mixer anymore.
That's an engineering optimization, and we should definitely explore it. Sure. But customization optimization shouldn't present 8 different languages to do it. You can write some in Go, some in C++, and some in Lua. I mean, then it's just a mess to maintain this.
Yeah, it gets complicated. Yeah, I totally agree.
Yeah, I think to what Nandan was saying before, Istio works if the proxy is super reliable and simple and lightweight and fast. And if we start putting all kinds of custom user-written code in Envoy and distributing it to all the envoys in the mesh, we now have a distributed app server. It's not going to make anybody happy. So we just need to be, we went down this road with Apogee, and we hear about it all the time. It would be great to be careful about that.
So how heavy duty or how expensive is the Lua engine?
Oh, I'm sure it's cheap, but if you can, calculate your blockchain in it, then someone's going to do it. And maybe it's their problem, but someone's going to, someone's going to run World of Warcraft in a Istio proxy and be in trouble. I'm exaggerating slightly, but
So
it's open source, so do whatever you want.
From having added support for this these use cases in CF, a majority of the use cases were not how to enable the developer of a microservice to program their own filters, but how to enable an operator to inject a service which already exists, which they're already paying for, which may be an appliance, into the request path. So nobody wants to write an adapter. Nobody wants to write a filter. Nobody wants to write Lua. I've already got this appliance. I want to send requests for some services through it.
Yeah. Yep.
If that's true, then it just has to be the proxy type design.
Yeah, and proxy type design does solve most use cases, I think, and independently, what Mixer can solve, Mixer can already solve, right? Including getting first 100 bytes and injecting more headers back into the stream and affecting. Because I think there is like a narrow strip of use cases which that particular mediation model is going to solve, but for other things, the stuff that Shannon just mentioned, we are going to have to inject a whole proxy. anyway. There is no substitute to that. So why have two ways again there?
Okay, so I propose that we write a quick little summary of this that just says, here are the core mechanisms that we want to add to the core features we want to add to Mixer in general.
Mm-hmm.
And then I think I'd be happy for now. We choose this pattern of just inserting a proxy. If we can figure out, I guess I'm in favor of the via pattern as our first foray into this space, augmented with these Mixer features.
With the context being passed.
Yes, with the security context being propagated, right?
Yeah. So ultimately,
we'll have to work on that a little, but still, yes.
Is via, is that an array then, or is that a single value?
We're already over time, so I don't think we can answer any design questions about that mechanism.
Pretty critical.
Okay.
All right. Well, thank you very much. Let's continue the discussion later.
Yes. All right. Thank you all.
Thank you.
All right. Bye.
Thank you.